Hello and welcome back to another episode of Middle School Math with Dr. Koenig. I'm so glad you're here. Today we are talking about rational number multiplication and division. So rational numbers encompass a lot of numbers. It encompasses whole numbers, counting numbers. It encompasses decimals, fractions, negatives, everything. But in this video, we're focused on decimals, positives and negatives, but decimals specifically. All right, so let's jump right in. Here we are multiplying negative 1.9 times negative 1.2. And to multiply rational numbers, to multiply decimals, we actually multiply a lot like we would normally with whole numbers or counting numbers. And we kind of ignore the decimals until the very end. So the first thing I'm going to do is write down 19 times 12. So it's not exactly 19 times 12, but when we multiply, we pretend as if it is from the get-go. So I'll multiply 2 times 9 is 18. 2 times 1 plus 1 is 3. So I'm done with this step. Then I'll multiply the 1. Remember, your second row in multiplication always starts with a 0. Then we start multiplying. 1 times 9 is 9. 1 times 1 is 1. From here, just like any old multiplication problem, we add these numbers together. So 8 plus 0 is 8. 3 plus 9 is 12, carry the 1. 1 plus 1 is 2. Now here's where that decimal comes into play, and in fact where we need to make a decision about positives and negatives. So I know my value is 228. Now I'm going to look back at my problem and see that I had two negatives, and two negatives of course equal a positive. So I know it's positive 228. And when we look back at our problem, our original problem, we count how many decimals there were in the original problem, and I see two numbers behind the decimal point, which means in my answer, I need two numbers behind the decimal point. So I'll start from the right side, and I'll move over 2 times to find that my final answer is positive 2.28. All right, here we go. We're doing it again. This time I gave you some bigger numbers to work with, or some different looking numbers, essentially. Now remember, when we're multiplying decimals, we really are going to ignore that decimal place almost the whole time. Not until the end will we really focus on it. Now that 0.9, I'm just going to write down a 9 and pretend as if it was a 9. The 0 won't help me. Remember, when I multiply anything by 0, I get zeros anyway. If there was a 0 in the middle of a number, let's say it was 0.905 or something like that, I would not ignore that number. But because it's at the very beginning, I can treat this as just a 9. So let's multiply. 9 times 8 is 72. 9 times 7 is 63, but then we add that 7 to get to 70. 9 times 3 is 27, plus 7 is 34. So I know my answer is going to be 3402. It's going to be those digits in that order. The question is, will it be positive or negative? And will it be, 34.02, 3.402? Where does that decimal go? So I will go back to the decimals in my problem. I see that I have 2 behind the decimal place and then 1 behind the decimal place, so that's 3 altogether. So in my answer, I'll start at the back and hop over 3 times. So you always start from the back. That tells me that my answer will be 3.402. And then when I look back at the original problem, I see that it's a negative times a positive, which of course we know is a negative. All right, so we've got 2 examples of multiplication under our belt. Let's try some division. Now with division, there's something really specific here. We always want the divisor, the second number, to be a whole number. In this case, of course, you can see it is not a whole number. So we need to change these numbers a little bit. Now, we are allowed to move the decimal over 1 place as long as we do it to both numbers. But what's really happening when we do that is we're just multiplying both of these values by 10. Now, think to fractions, although this is not a fraction problem. Remember back to fractions where if we had 1/4, we could maybe get common denominators or something if we multiplied both the numerator and the denominator by the same thing. That was one way we got common denominators to add or subtract, right? This is a different looking fraction, but it is equivalent to 1/4. We're doing the same thing here with these decimals. We're multiplying by 10 to get something that looks a little different. Now we have negative 53.1 divided by 3. It looks different, but it is an equivalent problem, much like when we got common denominators with fractions. From here, we want to do long division. So the second number is a whole number. That's how I know I can get started. With long division, I put my 53.1, my first number, that's called a dividend. The first number, dividend, goes in the division box. The second number, the divisor, goes outside the box. And then I just start dividing. So I can see that 3 goes into 5 one time, which of course is 3. Subtract, and I get a 2. Bring down a number. 3 goes into 23 7 times, that's 21. Subtract and get a 2. Bring down the next number. Now, you'll notice that my 1 that I brought down is after the decimal place. So I'm going to go into this problem and bring my decimal place straight up into my answer so that it does not get lost. And now I have 3 going into 21, which I know it goes into evenly. That goes in 7 times and gives me the 0 that I'm searching for at the end of my problem. Now, just like at the end of a multiplication problem, I do have to go back to the problem and look at what it was asking, but this time it's not to change anything about the decimal. Once we've moved them at the start, we actually keep our answer exactly like it is. It's 17.7. The only reason I'm going back to the problem is to decide if it's positive or negative. In this case, negative divided by positive is negative, so that tells me my answer is negative 17.7. Let's try one more division problem. These are a little trickier, so it just helps to see a couple of them. Here I've given you one that's very similar, but it has a larger number to work with. So just like before, I'm going to look at my divisor, which is this 1.2, and I need to move the decimal to make it into a whole number. You'll notice that my first number, my dividend, is not going to be a whole number. That's okay. It's really only the divisor, the second number, that we're tuned into. Once I multiply both things by 10, and I move that decimal over one place, I can see now that I have negative 100.8 divided by negative 12. I will take that problem and move it into an actual division box, I guess, for lack of a better word. So remember the dividend, the first number goes inside the division box, division bar, and the divisor, the second number, goes on the outside. So here I really have to know my 12 facts. So let's jump into this. I know that 12 doesn't go into 1. I know it doesn't go into 10. So it goes into 100 some amount of times. Now I know that that number is 8 because 8 times 12 is 96. If you're ever unsure, it's okay to go off to the side and say, let me try something. What's 12 times 7? Oh, I think it can go in an extra time. What's 12 times 8? Oh, look, that's close to 100. That's an okay process. If you're not super comfortable with your multiplication facts on 12s, maybe it's 15s, maybe it's 14s or something, it's okay to go off to the side and do some work to figure out what number you should use next. Now, in this case, I used 8. I got 96. I subtracted and got a 4. I will bring down my 8. And I'm noticing that my 8 that I'm bringing down is on the other side of the decimal, so I need to bring my decimal up into my answer at this point. Now 12 goes into 48 nicely because 12 times 4 is 48, leaving me with the 0 I'm looking for. Again, I'll go back to my problem and I'll see that I was dividing negative 10.08 by negative 1.2, which would give me a positive 8.4. Now remember, when you're solving these problems, the answer you get should make some sense. So in the original problem, I was dividing 10 by a little bit more than 1. 10 divided by 1 would be 10, right? So I'm looking for something that's kind of close-ish to 10. If I got my decimal in the wrong place and I thought my answer was, let's say, 84, or if I put the decimal in the front and I got 0.84, I would know that neither of those answers is anywhere close to 10, so I'm pretty far off. So use that judgment about what is the question really asking to help you figure out, am I at least on the right track with my answer? Here, I was on the right track because I was close to 10. All right, so the big overview, the nuts and bolts, the things you have to take away from this is, in multiplication, pretend like the decimal's not even there, multiply the two numbers, and then at the end, count how many decimals were in the original problem and make sure your answer has that same amount of decimals. In division, remember that the divisor, the second number, needs to be a whole number, so you might have to move that decimal over. You might even move it over twice, as long as whatever you do to the divisor, you do to the dividend also. So that's all I got for you. This should give you a start on multiplying and dividing. We certainly did not cover every single example, but this should lead you in the right direction when you're solving with decimals and you're looking to multiply or divide. I'm glad you stopped by today. Check out my channel if you're looking for math tutorials specifically related to middle school, 6th, 7th, and 8th grade skills, and I'll see you next time.